Hi everyone, my name is Abhinharshan Senthil and I'll be presenting my milestone 4 for ISTM-622. So this project is mainly focusing on two main areas. One is optimizing clustered MariaDB performance and implementing advanced AI-based data preparation techniques. So it builds on the earlier milestone where the emphasis was on data modeling and pipeline development and advances towards real-world performance optimization and AI integration. So in this presentation, I'll walk you through the key components, technical implementation details, challenges, and results achieved through this milestone. Moving to the next slide, that is the overview slide. So the project is structured around the four major components. First, I worked on the MariaDB cluster troubleshooting and performance optimization, focusing on the stability and query tuning. Second, I designed and implemented an advanced ETL and data pipeline capable of handling multi-source data ingestion efficiently. Third, I incorporated AI-driven vector embeddings, enhanced data research and recommendation capabilities. So finally, I focused on refining data preparation and feature engineering to create AI-ready datasets that can serve downstream analytics and machine learning applications. Together, these elements create a cohesive architecture that combines traditional database engineering with emerging AI capabilities. Moving to the next slide, MariaDB cluster troubleshooting and performance. So let's begin with the cluster troubleshooting and performance tuning. So MariaDB cluster, based on the Galera replication framework, offers high availability but can be prone to issues like certification conflicts and split brain conditions. The primary goal here was to ensure stability, fault tolerance, and optimal performance across multiple nodes deployed on AWS EC2 instances. So I approached this with a systematic diagnostics framework that is identifying node level failures, replication latency issues, and transaction conflicts that could affect cluster health and throughput. So for this, I will show you what I have done. The screenshots are already provided. So basically, I've took screenshots. I'll show you what I've done for this. I'll go to my EC2 instances. So these are the primary one of my Galera cluster. That is node 1. This is the node 2 of my Galera cluster. And this is the node 3 of my Galera cluster, which we have already done in milestone 3. So here we are on a troubleshoot and check whether it's working good or not. So basically, first we have to uh, connect to our three instances simultaneously. So it will be available over here on our EC2 AWS platform. So first we have to connect to both three of them, and we have to go to the root and enter the sudo nano varlib mysql graystate.dat and enter this, and then we have to enter this code Galera new cluster. And then from root, we have to go through the MariaDB. So MariaDB, we have to uh, tell which milestone we are using. That command is use milestone. And thus we are inside the MariaDB of our database, like milestone. We are inside milestone. That is our database name in MariaDB. So in order to check and confirm the cluster health and for saying that there are no quorum issues, we have a command called show status like WSREP cluster size. So here we can see the cluster size value is 3. So we can say the cluster is healthy. Also, some other command which we are using is this show status like local state comment. There also we are able to see empty. No, there also we are able to see that value coming as synced, which means it's working fine. So thus we are able to confirm the cluster health and no quorum issues. So moving on to the flow control analysis section. So here we are able to check the troubleshooting parts related to flow control. So the command for that is show status like WSREP flow control post. So over here the value is coming as 0, which means we are safe. Same another command which we are using for the flow control analysis is show status like WSREP local RACVQ. Here also the value is coming at as 0, which means the flow control analysis is working fine and we are not able to the Galera clusters troubleshooting is successfully done. Next, we can also check the certification conflicts. So here also we can see the values coming at 0. And the command that I used is show status like WSREP local failures. So we are good to go in this. So our now what we have to do is like analyzing the query performance. So for that, we can use the explain select statement. So for that, we can say that explain select star from orders where customer ID is equal to 2. So it is fetching the data successfully without any issues. So the query performance is not that much affected. Next, we can also, I have also checked for customer ID is equal to 3. Next, coming to the uh, next, we are gonna do the same on the primary node. We are inserting. We are gonna use the write queries on the primary. That is a primary one. So here also we are performing an insert function. So here I'm inserting into the basically I inserted into the categories table. Uh, so we can see that I've inserted the values of category D and category name, and we are able to see that it is working fine without any issue. So we are able to see that there is no bottlenecks or there are no other performance issues or anything in our nodes. Moving down, we can see. So in order to check if it is working fine or not, we can use another thing called show status like WS REP flow RECV queue statement. So here also an empty set is coming, which means our thing is working fine. I think for here also I've troubleshooted with something. Okay. So another statement is this RECVQ and this control post. So these two things are coming 0 as the overall database size is so small and the cluster is also small. That is why it is coming as 0. So moving on to our slides. So these are things, the screenshots which I put over here, I've explained them as a live demo. So moving on to the next part. So another change which we have to do is like we have to open the this file and we have to change the bootstrap to 1 so that it will be able to connect successfully. Moving on to the next slide, cluster and stability diagnostics. So during cluster diagnostics, I focused on the Galera node troubleshooting. For example, when conflicts occurred during certification on or when nodes temporarily desynchronized, I analyzed application logs and used WSREP cluster status and WSREP local state commands to access cluster state in real time. So I also use show global status like WSREP percentage to monitor key replication metrics such as flow control or latency and another transaction throughput. So this monitoring helped me quickly identify whether delays were caused by the network issues or disk IO limitations or transactional bottlenecks. As a result, I was able to resolve frequent desynchronization issues and maintain full cluster quorum under variable loads. Moving on to the next slide. Performance and bottleneck analysis. So these are things which I already explained. So once cluster stability was achieved, the next focus was performance optimization. I performed detailed bottleneck analysis across major transactional areas, that is product operations, customer data processing, and order management. The goal was to understand whether latency was being introduced and how query execution plans would be improved. So through systematic testing, I discovered that certain queries were performing full table scan due to the missing or inefficient indexes. I also noticed that table level locking was impacting concurrent transactions. Addressing these involved query plan analysis, index pre-structuring, and partitioning strategies to enhance concurrency and reduce execution time. So next is MariaDB diagnostics tools. So to support this tuning process, I utilize a set of MariaDB's inbuilt diagnostic tools. So that is explain and show status and MariaDB monitor. So the explain command was used to visualize query execution plans, revealing where the optimizer was failing to leverage indexes. And the show status command provided real-time insights into metrics such as handler read operations, table logs, helping to identify performance anomalies. Additionally, the MariaDB monitor allowed me to inspect active connections and threads, identify long running queries, and terminate block sessions that were degrading the performance. So combining all these tools formed a continuous monitoring framework that ensured the cluster maintained the optimal responsiveness even under peak workloads. So next is advanced ETL data pipeline design and implementation. So after stabilizing the database environment, I shifted to designing a robust ETL and data pipeline. The objective was to support multi-channel data ingestion from diverse sources, so including product catalogs, customer information, transactional data, and review text. So the pipeline was designed to be modular and fault tolerant, meaning each stage, that is extraction, transformation, and loading, that is the ETL, could function independently and recover from errors gracefully. The data architecture was built to maintain high data quality through strict validation and normalization processes before entering the analytical layer. So this design ensures both scalability and long-term maintainability of the data ecosystem. So this is an overview of what I have done. So next we are going to enhance data quality and transformation slide. So a key enhancement was the use of advanced SQL constructs to improve data transformation and quality. So mainly we have used Windows functions for running totals and ranking analytics, and also materialized views to pre-compute and cache expensive operations. So these features collectively improve query efficiency and maintainability. So to support analytics, I developed a data presentation layer using reporting views such as V underscore customer underscore summary and V underscore product performance to abstract uh, complex joins, simplifying reporting and improving query performance for the business analysts. So the result was faster reporting, reduced resource usage, and better support for business intelligence queries. So I will just walk through the query, through the code which is there with me for the creation of materialized views and views. So this is the query. So over here, I've used joins and group by for creating the views. So I created two views. One is a V customer summary. Another one is for the product performance related part. So these two views are created as part of the advanced SQL queries. So after that, I think I've executed the query and we are able to see all these things. Like this is a view for the customer related one, no order related one, and the product related customer related one and the product related one. That is done. So these are the two views which I have created. So these are the advanced ETL SQL features that I have created as part of this milestone. So moving on to next slide. So next slide is MariaDB vector embedding generation and similarity search. So the next stage integrated AI capabilities into the database environment. So I implemented a pipeline for vector embedding generation using language models. And what we are gonna do is like unstructured text data such as product descriptions and customer reviews were converted into 768 dimensional embeddings that capture semantic meaning. So these embeddings were stored directly in MariaDB as vector columns, effectively turning the database into a hybrid system supporting both structured and unstructured data. To accelerate the retrieval, I implemented approximate nearest neighbor indexing using HNSW algorithms. So this allowed sub-millisecond similarity searches even across the large datasets, a key performance benchmark for AI-driven applications. So if I go to the next slide, so we can see it is a continuation slide. So using these vector embeddings, I implemented semantic search and recommendation systems directly within the MariaDB. By leveraging the vector distance function, I enabled semantic similarity queries that could understand intent rather than relying solely on keyword matching. So for instance, a search for durable gear for wet trails would return semantically related products like waterproof boots or rain-resistant jackets. I also developed a recommendation system by comparing customer vectors with product vectors, enabled personalized product suggestions. So the broader impact is an AI-ready database layer that combines high-performance storage with intelligent data retrieval, eliminating the need for external AI indexing systems. So I can just walk through the Jupyter notebook and what all processes that we are doing as part of this. So first, we have to create a Google API, which is pretty understandable on the Jupyter because professor have given how to create a Jupyter API, how to create a Google API key on this file. So first we have to install these things, install Python libraries and all these steps. And this is the step where we are doing the configuration settings. So in this, what we have to do is like we have to create we have to give our public IP address of our instance. So for this, I will show you my instance is this uh, milestone 4. So this public IPv4 address I have to give over here. And then I have to change my database name over here and the username and password also if you're changing it. So once that is done, we have to execute our descriptions for existing programs. All these things we have to execute one by one. And after that, here we are looking for here we can see this is searching for a gadget for my kitchen. So based on the similarity, they will list as we are limiting the value to 5, it will only show find 5 relevant things. So based on the similarity, it will show in uh, descending order, like not descending order, ascending order. No, based on descending order, like 0.4692 is the first one, that is product what? Then product is happy. This is 0.4606. Then product Z special 0.64600. Like that, it will show. Description is also there. So next, if you check, you can also see similar searches happening like this. The word was positive, and they're finding 5 relevant products based on the similarity searches. So moving on to the presentation slide once again. So that is a screenshot which I've already explained. That is This is the thing where the similarity search is happening. So next slide is refined AI data preparation and feature engineering. So this is the final phase of the project that is focusing mainly on the refining AI data preparation and the integrating feature engineering support. So basically, I use ChatGPT and Google's Gemini as intelligent AI assistants to guide mainly in the API creation part, cluster troubleshooting, and the configuration of clusters and the performance optimization. For example, ChatGPT provided interactive troubleshooting steps during Google API setup and MariaDB cluster configuration. So I also employed AI tools to generate and test SQL optimization strategies more efficiently. Even though we have all these things and we are getting a lot of help from AI such as ChatGPT and Gemini, I think human AI collaboration significantly reduced the trial and error time and provided actionable insights for tuning and automation. But however, I found that while AI accelerates experimentation, expert dominant judgment, that is our judgment, it remains as an essential thing for interpreting diagnostics and making final optimization decisions. For example, AI is helping me basically in finding out some of the basic things. Like, for example, even my computer was so slow while executing the Jupyter cells, like Jupyter notebook commands. Uh, but I was not able to figure out why, but AI simply gave me a solution and it worked. So certain situations, AI is kind of useful, but for the coding part or configuration part or the MariaDB coding, whatever it is, we have to have some level of knowledge. We have to repeatedly ask and command or prompt AIs efficiently, then only we will be able to proceed further. So moving on to the next slide. So that's it. So I am gonna have an overall impact section on this. So first, the main overall impact of this milestone can be summarized by saying about the efficiency, scalability, and innovation. So from a learning perspective, this milestone helped me gain hands-on experience at the intersection of data engineering, database optimization, and applied AI bridging traditional and emerging technologies in a unified architecture. Thank you, guys. Thank you for your time and attention. So this concludes my presentation on Milestone 4. Thank you so much once again.